Today we're going to solve systems graphically. Students will solve systems of equations and inequalities by graphing. Before we get started, some vocabulary. Special types of systems. We have inconsistent systems where the linear equations have no answers. Basically, the lines never cross. We have consistent system where the two linear equations have at least one answer, meaning you can have an independent, which has one solution, or you can have a dependent, which has an infinite number of solutions. Remember, answers, or the solution, are only where the two lines cross. Let's take a closer look at the different types of special systems. A consistent and independent means that the lines are independent, they're going whichever way they want, but they are consistent, they only cross once. So they have different slopes and they're intersecting. There you go, there's your answer where they touch. Now, if they're consistent and dependent, that means that the one line is dependent upon the other. They have the same slope and the same intercept. Basically, they are the same line. So if you look at this red line, there's actually a blue line hiding underneath it. If they have the same line, they touch everywhere, and there are infinitely many solutions. Now, they're inconsistent if they never touch. It has the same slope and different y-intercepts, which means they are parallel lines. Here are the steps for classifying linear equations. First, put both equations in slope-intercept form. Then compare the slopes and y-intercepts. Then classify based on the chart. The instructions without graphing classify the system as independent, dependent, or inconsistent. First, I need to put them into slope-intercept form. I'm going to take this one off to the side. In order to get the y all by itself, I simply add the x to either side. It gives me 15y is equal to 3x plus 21. Then I divide both sides by 15. That gives me y is equal to 1/5 x plus 7/5. Always simplify. Now we do the same thing with the second problem. This one's a little easier. All I have to do is divide both sides by 25. And that gives me y is equal to 1/5 x minus 7/5. For both of these, we need to write the slope and the y-intercept. For the green problem, I have a slope of 1/5. For the blue problem, I also have a slope of 1/5. The y-intercepts are different, however. I have a positive and a negative. So we know that these two are parallel lines. Same slope, different y-intercept. If they're parallel lines, they are inconsistent with no solutions. The next problem says, tell whether the system has one solution, infinitely many solutions, or no solutions. We need to do the same thing, set it up in slope-intercept form. I'm going to add the 2x to either side, which gives me y is equal to 2x plus 4. Now make sure you write your slope, 2 over 1, remember it's always a fraction, and your y-intercept. Do it again with the green problem. We added the 10x to the other side, which gave us 5y is equal to 10x plus 20. Then we need to divide both sides by 5, which gives us y is equal to 2x plus 4. M is equal to 2 over 1, and our y-intercept is equal to 4. So this is consistent, dependent, and has infinitely many solutions. Another way of writing infinitely many solutions is to say all real numbers. Now, solving by graphing. Remember the steps for graphing. First, write the equation in slope-intercept form. Then write the slope and the y-intercept, graph that y-intercept, graph at least 2 more points using slope, draw the line, and the solution is where the two lines cross. So let's get started. The first one I'm going to rewrite off to the side so that I can work with it. I need to subtract 3x to the other side. Then I need to divide both sides by 9. Gives me y is equal to negative 1/3 x minus 3. Make sure we write out the slope and the y-intercept. My slope is negative 1 over 3, and my y-intercept is equal to negative 3. Now we need to do the same thing with the other problem. It's a little bit easier. All I have to do is move the x over. That gives me y is equal to negative x minus 5. Make sure you write your slope and your y-intercept. My slope is negative 1 over 1, and my y-intercept is equal to negative 5. We'll graph the blue one first. My y-intercept was negative 3. I go down to negative 3. I put a dot. My slope is negative 1 over 3. So that means go down 1 to the right, 1, 2, 3, put a dot. Down 1 over 3. And you can go the opposite direction also. Then simply draw a line through it. Now for the green problem, my y-intercept is negative 5, and my slope is negative 1 over 1. It means down 1, right 1, down 1, right 1. We can also go in the opposite direction, up and over, up and over. And then draw a line. Where the two lines cross is your answer. So we can look right here, they cross at that point. Now you need to label your point. Negative 3, comma, negative 2. So the answer would be negative 3, comma, negative 2. Moving on to linear inequalities. For a linear inequality, you basically replace the equal sign with a less than or greater than. The solution of a linear inequality is any ordered pair or point that makes the inequality true. So you plug them in, see if it's true or not. The solution of a system of linear inequalities is any ordered pair that makes all of the inequalities true. So if you have multiple inequalities, you need to see if they're all true. We can do this by substitution, or we can graph. It's actually, depending on the problem, can be easier to graph. So review graphing one more time. Slope-intercept form is y equals mx plus b, where m is the slope and the y-intercept is the b. A dashed versus solid line. You have a solid line with an inequality with an equal sign. You have a dashed line if there's no equal sign. Shading. For y greater than, shade up. If your y-axis is going up and down, greater would be growing. 1, 2. Getting smaller would be going down. So no matter where you are, if I'm going down, down is smaller. Up is greater. So for y greater than, we shade up. For y less than, we shade down. For this problem, we're going to solve by graphing. First thing we need to do is put our inequality into slope-intercept form. We're going to rewrite it off to the side. Now I need to solve for y. First thing I'm going to do is subtract the 2x to the other side. Remember, there's an invisible 1 in front of the y. In order to get rid of that negative, we divide everything by negative 1. Whenever you multiply or divide by a negative across an inequality, you always have to flip that inequality sign. That gives you y is now less than positive 2x plus 2. Make sure you record your slope and your y-intercept. My slope is 2 over the invisible 1, and my y-intercept is equal to 2. When I'm graphing that, I take the 2 and put a dot there, and then rise 2, run 1. Rise 1, 2, run 1. We can go backwards where I go down 2 and left 1. Now, because this is an inequality with no equal, it's going to be a dashed line. And we'll get to the shading in a second, but first let's do the other problem. First thing you're going to do is subtract the 3x to the other side. Then we can divide both sides by 2. Notice the inequality stayed the same because we did not multiply or divide by negative. Now all we need to do is write out our slope and y-intercept. My slope is negative 3 over 2, and my y-intercept is 3. So I go up to 3 and I put a dot. And my slope says to go down 3 and to the right 2. I go down 1, 2, 3 and to the right 2. And we can go backwards. Then you simply draw a line. Because there's an equals here, it's greater than or equal to, then we draw a solid line. But we're not done. Because this is an inequality, we need to shade things. So the first one I'm going to shade is the blue one. Now the blue one says y is less than. So go to our simplified problem, and it says y is less than. Well, less than is pointing down. So less than 2 is 1. Less than 1 is 0, etc. So we're going to shade everything on the bottom side. Now, move over to the second problem. That says y is greater than. So greater than is going up. So we're going to shade everything that goes up. So if I start at 3, 4 is greater than, 6, 8, they're all greater than. So we're going to shade the top side of this green arrow. Your solution is where the two colors combine to form green. So any point within that will be a solution. They're going to ask you questions sometimes that say, is this a solution? So if you're looking at it and they say, is 0, 6 a solution? You'll say, no, it's not. If they say, is 2, 0 right there on that green line a solution? You'll say, yes, it is. It's on the solid line. However, if they ask you about 2, 6 on the dashed line, you'll say, no, that's not a solution. It's not a solution because the dashed line is not or equal to. The green line, he is solid, which means it's or equal to. So anything within the green shaded area or on the green line is a solution. Here's another one that should be quick and simple. This one says y is less than 4. Well, we remember if there's no x, if it's just a y equals a number, then it's a horizontal line. In this case, a horizontal line at 4. Now, because it says less than, there's no equal, it's going to be a dashed line. And because it says less than, it's going to be pointing down. So we're going to shade everything down. Next, y is greater than the absolute value of x plus 1 minus 2. Remember, an absolute value is simply a v. You take the two edges, put them together to get a v. And the negative 2 on the outside tells you to go down in the y. And the plus 1, it's positive, so we need to go left. We go left 1 in the x. And that is our bottom. Now, if there's no number in front, we simply go over 1, up 1, over 1, up 1 in both directions. Because there's no equal sign, we simply keep a dashed line. Now, the greater than symbol tells us to shade up. If I'm down here at negative 2, up is going this way. So everything in the shaded green area is part of my solution. Here we have another one, but they were nice. The first one is already set up for us. The first one has a slope of 3 over 1 and a y-intercept of 1. I'm going to go ahead and graph it really quickly. Because it says or equal to, then I know that it's a solid line. Now for the other one, we're actually going to have to rewrite it and do some work. Add the 9x to the other side. Divide everything by 3. That gives you y is greater than. 9 divided by 3 is 3x plus 3 goes into 14 4 times with 2/3 left over. Now, why did I change it to a mixed number? Because I can't graph 14/3, but I can graph 4 2/3. So my slope here is 3 over 1, and my y-intercept is 4 2/3. I go over to 4 2/3 and put a dot. And then I go up 3 over 1. And do the same thing going the opposite direction. Because this was a greater than symbol, that means that it is a dashed line. Now we need to shade these. The first one we'll shade in blue. It says less than, which means it's going down. So if I'm at 1, what's less than 1? 0, negative, everything down will be less than 1. Then the other one says y greater than, so everything bigger. We started at 4 2/3, 6, 8, 10, everything there is greater than, so we're going up. Now you can see at no point in time will these lines cross because they both have the same slope. 3 over 1, 3 over 1. They also have different y-intercepts, and that means that these two lines are parallel. Now, because they're pointing in opposite directions as far as the shading goes, one's greater than going away and the other one's less than going away, then these two will never cross. That means the answer to this is no solution. All right, we have one more problem. It says, what shape do the lines create? So I have 4 lines here. Luckily for me, they're all in slope-intercept form. The first one, actually the first 2, we know are going to be horizontal lines because there's no x value. So it says y is less than or equal to 2.5. I go up to 2.5 and put a dot there. And it says less than or equal to, so I know it's going to be a solid line going through 2.5. Do it again at y is greater than or equal to negative 0.5. Go down to 0.5 and put a dot, and then draw a line through that. Next, we have y is less than or equal to negative x plus 8. For this one, we have a slope that equals negative 1 over 1 and a b that equals 8. Go up to 8, put a dot, and my slope is negative 1 over 1. Down, no. For the last one, we have y is less than or equal to 2x plus 4. We have a slope that's 2 over 1 and a y-intercept that's 4. Go to 4, put a dot, slope is 2 over 1, and then draw a line. Now we need to shade all of these. So if I look at the first one, it says y is less than 2.5. So I go to my 2.5 and I start shading everything less than. Then the next one says y greater than negative 0.5. So I go to negative 0.5 and I'm shading everything greater. Greater is going up. The next one is the red line. It says y is less than negative x plus 8. So y is everything going down below the 8. I think you can see where we're going with this. And then we have one more that says y is less than the negative 2x plus 4. So that would be y is less than the green line right here. Less than again is going down. So we're going to shade everything on the bottom of this. And because we have so many colors on top of each other, it's getting hard to see. So now I'm going to erase the leftover and only leave what is quadruple shaded. So you can see the piece we have there in the middle is the shape of a trapezoid.